Welcome to What is Hadoop? My name is Richard Kirshner with the Simplilearn team. That is www.simplilearn.com. Get certified, get ahead. Before we dive into the technical side of Hadoop, we're going to take a little detour to try to give you a visual understanding and relate it to maybe a more life setup. And we're going to go to the farm in this case. So we have in a farm far away. I almost wish they'd put far, far away. It does remind me a little bit of a Star Wars theme. So we're going to look at fruit at a farm. We have Jack who harvests his grapes and then sells it in the nearby town. After harvesting, he stores his produce in a storage shed, or a storage room in this case. What he found out though is there was a high demand for other fruits, so he started harvesting apples and oranges as well. Hopefully he has a couple fields with these different fruit trees growing, and he's set up there, and you can see that he's working hard to harvest all these different fruits, but he has a problem here because there's only one of him, so he can't really do more work. So what he needs to do then is hire two more people to work with him. With this, harvesting is done simultaneously. So instead of him trying to harvest all this different fruit, he now has two more people in there who are putting their fruit away and harvesting it for him. Now the storage room becomes a bottleneck to store and access all the fruits in a single storage area. So they can't fit all the fruit in one place. So Jack decides to distribute the storage area and give each one of them a separate storage. And you can look at this computer terms. We have our people that are the processors. We have our fruit that's the data, and you can see it's storing it in the different storage rooms. So you can see me popping up there getting my hello, I want fruit basket of 3 grapes, 2 apples, and 3 oranges. I'm getting ready for a breakfast with family, a very large family. My family's not that large. To complete the order on time, all of them work parallelly with their own storage space. So here we have a process of retrieving or querying the data, and you can see from the one storage space he pulls out 3 grapes, she pulls out 2 apples, and then another storage room he pulls out 3 oranges. And we complete a nice fruit basket, and this solution helps them to complete the order on time without any hassle. All of them are happy. They're prepared for an increase in demand in the future. So they now have this growth system where you can just keep hiring on new people. They can continue to grow and develop a very large farm. So how does this story relate to big data? And I hinted at that a little bit. Earlier, the limited data, only one processor, one storage unit was needed. I remember back in the 90s, they would just upgrade the computer. Instead of having a small computer, you would then spend money for a huge mainframe with all the flashing lights on it. Then the Cray computers were really massive. Nowadays, a lot of the computers that sit on our desktop are powerful as the mainframes they had back then. So it's pretty amazing how time has changed. But you used to be able to do everything on one computer, and you had structured data and a database you stored your structured data in. So most of the time you were querying databases, SQL queries. Just think of it as a giant spreadsheet with rows and columns where everything has a very specific size and fits neatly in that rows and columns. And back in the 90s, this was a nice setup. You just upgraded your computer. You would get yourself a nice big Sun computer or mainframe if you had a lot of data and a lot of stuff going on, and it was very easy to do. Soon, though, the data generation increased, leading to high volume of data along with different data formats. And so you can imagine, in today's world, this year we will generate more data than all the previous years summed together. We will generate more data just this year than all the previous years summed together. And that's the way it's been going for some time. And you can see we have a variety of data. We have our structured data, which is what you'd think about a database with rows and columns and easy to look at, nice spreadsheet. We have our semi-structured data. They have emails as an example here. That would be one example, your XML, your HTML, web pages. And we have unstructured data. If you ever look through your folder on photos, I have photos that were taken on my phone with high quality. I've got photos from a long time ago. I got web photos, low quality. So just in my pictures alone, none of them are the same. You know, there certainly are groups of them that are, but overall there are a lot of variety in size and setup. So a single processor was not enough to process such high volume of different kinds of data, as it was very time consuming. You can imagine that if you are Twitter with millions of Twitter feeds, you're not going to be able to do a query across one server. There's just no way that's going to happen unless people don't mind waiting a year to get the history of their tweets or look something up. Hence, we start doing multiple processors. So they're used to process high volume of data, and this saved time. So we're moving forward. We got multiple processors. The single storage unit became the bottleneck due to which network overhead was generated. So now you have your network coming in, and each one of these servers has to wait before it can grab the data from the single stored unit. Maybe you have a SQL server there with a nice setup or a file system going. The solution was to use distributed storage for each processor. This enabled easy access to storage and access to data. So this makes a lot of sense. You have multiple workers, multiple storage units, just like we had our storage room and the different fruit coming in, your variety. You can see that nice parallel to working on a farm. Now we're dealing with a lot of data. It's all about the data now. This method worked, and there were no network overhead generated. You're not getting a bottleneck somewhere where people are just waiting for data being pulled or being processed. This is known as parallel processing with distributed storage. So parallel processing, distributed storage. And you can see here the parallel processing is your different computers running their processes, and distributed storage. So what's in it for you? Well, today we're going to cover big data and its challenges. We're going to look at Hadoop as a solution, because this is all about what is Hadoop. Hadoop is like probably one of the biggest growing file systems out there that people have now gone to, and there are a lot of varieties of Hadoop. I was surprised when I started digging into it how many offshoots that do different things and are specialized. But the main Hadoop package is very widely used. And we'll get a little bit more into what exactly is Hadoop and some of the components of Hadoop. And then we'll look at a quick use case of the Hadoop system that was used in one of the companies. So what is big data? Massive amount of data which cannot be stored, processed, and analyzed using the traditional ways. And so we look at this and we have volume. Most people think of volume with big data. And I'm going to tell you right now, volume is not the only measurement of big data by far. You don't have to have a big volume for it to become big data. Volume is the most common one that we see. Velocity, how fast is that data being generated? So as you have your volume, but you might have a huge amount of data that's just streaming in. You can't just process it on one computer. You need to process it on multiple computers and then send that to the appropriate storage spaces. Variety. When you look at variety, every step you do to go through, it might be very simple to do like a spreadsheet, but now you have to look at the email and how it's stored, so it needs a different process. You have to look at HTML pages and how they're stored. That's a different process. Each one of those processes generates resource usage. And so one of the big problems is when you have a huge variety of data coming in, all that pre-processing now takes up a lot of resources. Value. Value is always the end result. So a lot of times when you reduce down whatever process you're running, you have to reduce those down to a certain value that someone like the shareholder can look at and say, oh, this is good value. We're getting the value for our data we're processing, and this is what we're going to get out of it. This is where your mission statement is, and reducing it down, and I'm using the term reduce very specifically. You'll hear that a lot, and we'll talk about map reduce later on, but we want to reduce everything down so that people can use that data. We want to reduce the variety down to some hard facts. We want to reduce that huge amount of velocity coming in, process it, and reduce it down to a nice chart you can look at. So it has value. And then veracity. Now, veracity is a strange one. You see the term, and you can look at ferocious or veracity. This terminology for big data means that the data has a lot of uncertainty to it, which adds a huge amount of processing. For example, Twitter. We look at a Twitter account and somebody puts weird capital letters. They misspell. They do abbreviations. They do all this weird stuff that goes into that data so it doesn't look right. And we have to process it. Well, that takes a lot of processing. You have to have some kind of storage that maps it out. You have to have some kind of system to guess what it is. And so veracity becomes a very huge node on big data. It used to be they had the 3 V's and then the 4 V's. Now they have the 5 V's. I've actually seen like 17 V's. I think they're overdoing it. But when you're looking at big data, knowing about veracity is really important. That can really use up a lot of tasks. And anything that takes up resources is becomes a factor of if it's big data or not. If it utilizes more resources than you can process on one computer, you're now dealing with big data. And we'll add in a timely fashion. Certainly my computer could do a lot of stuff if I don't mind waiting a million years for it to finish iterating through. I think my hard drive has like 5 terabytes on it. I have processes that even across 1/10 of a gig take 5 hours to run. 5 hours to run that same process, if I had 10 terabytes of data, would not finish in my lifetime, at that rate. So big data, challenges and solutions. So we looked at a lot of the things that define big data, which also define the challenges in big data. So those are all important. So having a single central storage, that's a big challenge. So we do a distributed storages. Now, when we talk about distributed storages, we're not talking about around the world. We're not talking about you have one computer in the US, one in India, one in Australia. We're talking about you have a rack of computers, or 2 racks, or 3 racks, or 100 racks of computers. And so instead of storing it on one machine, you now store it across all those different computers, and you can just keep adding them on. And there are cases where you can split those, so you have 2 different processing areas that back up to each other, but that's a whole nother animal, because now you have that data transfer and the processing causes issues the further apart, the more connections you have to get and the bandwidth going between those servers. So we're talking about racks of computers here. Serial processing. So one of the challenges when we had a serial processor, you have one processor, one output, one input. Now you have parallel processing, so you have processes A and B, and then they have your output going out. And then the lack of ability to process unstructured data. And this was like really where Hadoop started becoming big, was all this weird data were accumulated, all this unstructured, structured, semi-structured data. Now that you have a way of actually storing it and processing it that makes a lot more sense in the Hadoop system. That was a big challenge. And so the ability to process every type of data becomes one of the big solutions of big data that's needed. And of course we're talking about Hadoop as a solution. There are other solutions out there. Hadoop just happens to be the most, it actually pulls in all the different parts and is the most commonly used one and is highly developed, and it's been around for a while. So what exactly is Hadoop? Hadoop is a framework that manages big data storage in a distributed way and processes it parallelly. So we've been talking about this now for a little bit here, so this shouldn't be a big surprise. We have our big data, we need to store it, and we have our processing and our analyzing of it. So we need to do something with that data. Components of Hadoop. So how does the Hadoop system do what it does? So let's look at the components of Hadoop. We have our Hadoop setup, and then you have your Hadoop HDFS, which is the storage unit of Hadoop, or Hadoop file system, is what the HDFS stands for. And then you have your processing in Hadoop, which is your map reduce. And you heard me earlier talk about reduce, not just for where it fit up there, but also understanding its functionality in processing data. So let's start with the Hadoop file system. Hadoop Distributed File System, HDFS, is specially designed for storing huge data sets in commodity hardware. So we have name node, data node, and I'll come back in just a minute, commodity there. We have name node, data node. Our name node, there is only one name node. Now in the newer versions of Hadoop, there's a backup name node, but only one is active. Only one is processing everything. And there can be multiple data nodes. So you have all your racks of computers. In this case, we have 3 data nodes, but usually there's at least 5 to 10. That's very rare to see a company spend a lot of money on a rack that's less than 5 data nodes for storing their Hadoop file system. That's not to say that there isn't reason to do that. Point that out in a minute. But certainly there can be multiple data nodes. And I wanted to go back to the components, and we talked about, let's go back here, commodity hardware. So where does commodity hardware come in? Why is that so important in the Hadoop file system? Well, we have the name node and the data node. Imagine you want to go buy 100 servers. Well, if you buy an enterprise version of that server, it's going to run about $10,000 per terabyte for the full processor, and you get a lot for your money for $10,000. At $10,000, if you're buying 100 of them, that's a lot of money. So when you're talking about a commodity system and your data nodes, what if we could do it in a commodity computer that for a terabyte runs about $1,000? Well, now you're only spending $100,000 versus spending $1 million. The name node is almost always an enterprise computer. Obviously if you're doing a small testing rack or something like that, you might just use a commodity computer as your name node to test it out. But in actual production, that's almost always an enterprise computer. That's one of the points of failure. So you need your name node to be the high end. But Hadoop is set up so now you can do your data nodes as commodity machines. And we talk about master-slave. Master-slave nodes typically form the HDFS cluster. So you have your master, which is your name node, the one in charge, and then you have your data nodes or your slaves. So your master controls the slaves and gets them to do all the work. Name node maintains and manages the data node. It also stores the metadata. So it stores what's going on across the Hadoop file system. Data nodes store the actual data. They do the reading, the writing, and processing. They perform replication as well, so there's replication of the data across the system. And finally, we need something to tie them all together so they're all connected. Well, we have this nice picture of the heartbeats. A heartbeat is the signal that data node continuously sends to the name node. This signal shows the status of the data node. So they're continually sending them a little pulse saying, hey, I'm still here, everything's good. And of course, when that disappears, then all the pagers of the IT department go off and you see all these guys run to the server room. In HDFS, data stored in a distributed manner. So we're looking at 30 terabyte file. That's a pretty big file. Even on my high-end computer, it's rare for me to have more than 5 to 10 terabytes on a desktop, computer sitting on my desk that I'm working on. Most computers probably have a 1 terabyte hard drive. So 30 terabytes is pretty big. The 30 terabytes of data is loaded and it goes into the name node. And then the name node distributes that around. And so in this case, we divided it into 128 megabyte each. And we'll designate the blocks with blue, red, and kind of a tan color or gray. So we have our data nodes. And so we go ahead and distribute that data across those data nodes. And you'll see here that we might put the blue block, one computer in the first column. And then you'll see that not only is it on the one computer or the one machine, blocks are then replicated among the data nodes. So now in this first row, you'll see that it is replicated 3 times. And that is the default. The default is to replicate the data 3 times so that if one of these commodity machines, remember commodity versus enterprise, if one of these commodity machines goes down, you can swap a new one in and it's cheap. Commodity machines are more likely to fail, that's why they're cheaper. Best description I heard was they're a cheap knockoff. The Chinese knockoff is the way they actually rephrased it, although they're made all over the world now. So features of the Hadoop file system or the HDFS. It provides a distributed storage implemented on commodity hardware and provides data security. So this is that replication part where you don't have a RAID backup or a high-end backup. The nodes themselves are replicated 3 times, and so it's backed up in 2 different places. And it's highly fault tolerant. So if one machine goes down, it just pops over to the next machine and does its stuff on there. So we've looked at the Hadoop file system. We visited over there to our storage unit of the Hadoop and how it stores the data. Let's go ahead and look at the Hadoop MapReduce, processing unit of Hadoop. Hadoop MapReduce is a programming technique where huge data is processed in parallel and distributed fashion. And when we look at this, because in Hadoop, the MapReduce is how it queries the data and how it functions, which is important to know. Also think about the process, because thinking MapReduce is also very important if you're in the programming side. So whether you're looking at how the system works or you're a developer, knowing how that functions is important. So we have our big data and we have our processor in the Hadoop MapReduce. The MapReduce is used for parallel processing of big data, which is stored in the Hadoop file system. And then it puts your output out. Remember we had value. We want to reduce this to something that people can look at and has value. So when you go to the head of the company, you're like, yeah, see what I got for you? You paid all this money for this data storage and everything. Here's the value for you. Here's your output. In MapReduce approach, processing is done at the slave nodes and the final result is sent to the master node. So we have our different slaves that are connected to our master, or name node, and data nodes. The traditional approach for data is processing at the master node. And you can imagine that if I have my one server and I try to put 10 terabytes of data onto it to process, it has to come from all those different computers. So you have your bandwidth of that data coming across, which is going to take time to transfer it. Every time you want to do a process, your master computer, if you don't have 10 terabytes of RAM, which I don't know very many computers that do, isn't going to be able to process it. So it still has to process it in pieces and it still causes a mess and can't even do it in many cases. So in this case, with MapReduce approach, data is processed at the slave nodes. The code we use to process that data is usually very small in comparison to the data itself. I'm only sending a couple kilobytes worth of code to do a heavy process on the end computers. So, much more, imagine if you had to do the farmer at the beginning and they had to bring all the fruit into one spot before they could distribute it. By the time they got it distributed, it'd be all rotted and fermented. They wouldn't be able to do it. They'd have only one person sitting there mushing it together. So what is MapReduce? So let's start with taking a look and really both understanding how this works in the Hadoop system and thinking MapReduce are an important part of development and understanding both the admin side of it and the programming side of it. And so we'll start with an input. The input in this case has 3 lines of text. So we have 3 separate entities. We have bus, car, train, ship, train, bus, ship, car. And so we split that up into our 3 entities. This might be, if you're in a database, it might be a row in you have row and columns, it might be your rows. Each one's going in and we're going to process that row, just one row at a time. So the input data set is first split into chunks of data. And we do the map phase. And the map phase is any process you can do on that chunk of data that does not require any other data. So if this is this one line, this is that one Twitter feed that we want to figure out what's in the Twitter and what its value is. Let's go with Twitter. That's an easy one. You send a text message, bus, car, train. Why you're twittering about bus, car, train, I don't know, but you are. But let's look at that, and we can now count those words. And so in this one line, we have bus 1, car 1, train 1. And this would be any process you could do on that one individual line. Now, when we map it, we almost always give it a key value, a key and a value. So our key in this case is bus, car, train, and ship. Those are our keys. So we have bus 1, because we have one bus, we have car 1, we have train 1. And in our next one, we map it, we have ship 1, train 1, bus 1, ship 1, car 1. It might seem strange that I'm mapping it this way, because I could map this ship 2, train 1 for the second one. You can do it either way, but it actually functions quite well to leave it as this setup. There's reasons to do it the other way, reasons to do it this way. But so we have a mapping. We have our keys and we have our values. And let's say we want to know the total uses of all the different words in here. So we're going to shuffle, and we're going to shuffle and sort. And we sort them out. And what we're going to do is we're going to group all the buses together, anything with the keyword bus. We're going to shuffle all the cars together, all the ships together, all the trains together. And the data we're processing is we're just doing a simple count. This could be very complicated data you're processing instead of just a one. And so now we have bus, cars, ships, and trains, and then we reduce phase. And the reduce phase is, at the reduce task, the aggregation takes place and the final output is obtained. So instead of having thousands of lines of counting, we just sum it up. And this is kind of nice because you can see that we have 2 buses, 2 cars, 3 ships, 2 trains. If you want to just get a count of how often these different words are used. And simple word counts is really the start to do an analyzing Word documents and things like that, is to know how many uses of a certain word is in there. In the map and reduce, you really want to take apart, you really want to notice we have our input, which is our data. We have our split, so we're splitting each one of those into something that makes sense. Maybe it's by the document, maybe it's by the Twitter feed, maybe it is by the email, maybe it's by a row in a database. We then take that, anything we can do on that is mapping, so we map that data and we attach it to a key. The key is how we're going to shuffle and sort it. This shuffle and sort is all handled by the MapReduce setup. Then we have our shuffle and sort, which handles getting all those keys together, and finally under the shuffle and sort then goes into the reduce phase where we get our final answer. So components of Hadoop version 2, remember we said there's a version 3 out which is in beta test at this time. Version 2, we have the storage unit of Hadoop, the HDFS. We have Hadoop Yarn, which is our resource management unit of Hadoop, and we have our Hadoop MapReduce. Let's touch upon the middle one. We haven't talked about that yet, the Hadoop Yarn. Yarn, yet another resource negotiator. So the Yarn is basically your Hadoop operating system. It acts like an operating system. Now it's not actually an operating system because it's not controlling any one computer. It's controlling everything across all the computers. But it acts like, just like your PC, Windows OS, or Apple OS, or Linux. So it acts like that. It's a file system that sits on top of everything. And it's responsible for managing cluster resources, knowing where everything's going, and making sure you don't overload one machine while one doesn't get used. And it also does the job scheduling, making sure they're scheduled in the right place. So what is Yarn? So let's go ahead and take a look at Yarn. We have a client. Now, the client machine is you on your laptop, whether it's you're doing a query, you're putting together some code to do some data analysis. So we have our client machine, and the client machine submits the job request. So it sends it out there and says, hey, I want you to query all all the word count for all these Twitters between the current political candidates that are running. I want to see what words they're using in their speeches. And the client machine then goes to the resource manager, or Yarn in this case, which is responsible for resource allocation and management. And so we have each of our node managers, and the node manager manages the nodes and monitors the resource usage in the node. So we have a resource manager which sits on top of everything, and then our individual computers each have their own manager managing that machine and what's going on. And then we have a container. Container is a collection of physical resources such as RAM, CPU, hard drive. So you can think of that as however you can store it. You might have 8 core processors on that computer and 128 gigabytes of RAM and a 10 terabyte hard drive. That's all part of the container. So where are we going to put the physical resources in when we're working with them? And you have an app master. The app master requests container from the node manager. So your app master says, hey, node manager, I have a process going on. I need so much RAM and so much CPU. Can you do that for me? And these all go back to the resource manager, which is in charge of the overall big picture. So let's go ahead and take a look at the use of Hadoop. Why do we want Hadoop? What is the end result? What can you use it for? And there are so many use cases. There's so many companies using these in the big data setup. But we're going to look at fraudulent activities in one case study. So we're going to do Hadoop use case combating fraudulent activities. And they start by detecting fraudulent transactions as one among many of the various problems any bank faces. And this is also true of almost any online business, but big for banks. You have your money that's being stored there, and you have a lot of fraud activities that come in from all kinds of different directions where people are trying to rip the bank off. In this case, the Zions Bank Corporation, their main challenge was to combat the fraudulent activities which were taking place. Approaches used by Zions security team to combat fraudulent activities. Security information management, or SIM tools. So we have our security, our SIM. And so the problem is it was based on an RDBMS data set. And they were unable to store huge data which needed to be analyzed. So in other words, they certainly were able to analyze small amounts, but they have such a flood of customers coming in, and there's so many different things that they really didn't have a way of tracking all the different data that they had available to them. So they began by doing parallel processing. Problem also was unstructured, and analyzing was not possible. So a second problem they had, not only did they have a huge amount of data that they couldn't get to in their databases, they also had unstructured data, different emails going back and forth, say between the people, the loan officer and the person getting a loan. Batch files generated from errors, or there's all kinds of things that come in there that have no organized, that are unstructured data or semi-structured data that don't fit into the regular RDBMS. I mean, you think of the RDBMS, you have your customer, how much money they have on hand, what their credit score is, etc. And then you have all these emails that go back and forth, or phone conversations, or all kinds of different things that they can pull from there that's unstructured. But all that can be dumped into Hadoop system, and it's very affordable to do that compared to doing it across enterprise machines. So this is how the Hadoop solved the problems. Zions could now store a massive amount of data using Hadoop. So they can now pull all that data together and store it in one place to look at it. Processing of unstructured data, like server logs. Remember, we're talking about the different data. Server logs are big. Customer data, all those emails going back and forth. Customer transactions, which is more structured. Usually you have like they took a loan out for X amount of dollars, X interest. Now it's possible to process that a huge amount of data across the Hadoop file system. And analyzing. Because you can do this, you can now do in-depth analysis of different data formats. It's easier and more time efficient. Remember, I think I mentioned that earlier. I said, I could certainly do this on my computer. I could hook up a massive series of hard drives. They're cheap nowadays. But if I did that and I wanted to process all this data on my computer, it would probably be done in about 1 million years to do the same analysis. Now we can do it over the course of a couple weeks or a month. Last year's data comes in and we do our analysis. And so the team could now detect everything from malware, spear phishing attempts, to account takeovers, where someone has illegally figured out how to log in by the way they log in. And oh boy, do I like that one. I have my bank account where they send me a note. They say, you have some activity that might be fraudulent on your account. Did you buy motorcycle parts in wherever it was? No, I've never been there. So this process saves the bank money, saves their clients money, and is just good business. So let's look at some key takeaways. We looked at what is big data, and we talked about volume, velocity, variety, value, and veracity. We looked at what is Hadoop as far as a storage system, processor, processor and analysis. Underneath the storage, we looked at the Hadoop file system and its features. We went over MapReduce, which is the processing, and then what is Yarn, which is what's behind all this, what's going on behind the scenes. Yet another resource negotiator. I always want to call it navigator, but it's really a negotiator where they're shaking hands and negotiating deals. And then we looked at a use case where we're combating fraudulent activities. So I'd like to thank you for joining us today. For more information, come visit us at www.simplilearn.com. Get certified, get ahead. You can also leave messages in the YouTube below, and we do have somebody who monitors our YouTube channels. Again, thank you for joining us. www.simplilearn.com. Get certified, get ahead.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.